Right, so we just have one absent today, that is Michael. His mama, sometimes he is well. He went to school. He came in our thoughts, right? So, with every class, I just wanted to always remember, class is a safe space. You know what that means? What that means?
Talk freely.
Speak freely. Yeah. But
Speak comfortable.
comfortable, be comfortable with
Don't be afraid to ask questions.
Don't be afraid to ask questions. Right? Same thing on the board there, right? So you must always respect each other, because the same way you would like to say something, you don't want somebody over talking you. So when somebody else talking, we give them that respect, right? And we all understand, learning is about question. You understand something, you ask me, you ask your friend, that's how we learn. Right? Asking questions. And at the end of the day, we all like to learn, right? It's not a competition with the person, a competition with his themselves, right? Let's try to be better than the person who was yesterday and the day before.
One weight won't weigh on one side. And they weren't out. They were just a little dimmer than the others. And I tried to let it go, but I couldn't. It bugged me. And so what that really meant, of course, you can guess, is I had to take a third of the ornaments off the tree at the top, unwrap the lights, and put the new strand in. Which really didn't take me too long, but the tree's pushed up against a corner with a couch on the other side, and so it's hard to get at. And so I kind of tried to take those strands off and then put the other one on by reaching around and pulling them, and it just looked horrible. Now, I did this because I thought that getting down on my butt and pulling that tree out the 3 or 4 feet that I needed to walk around it was going to be a huge hurdle. And that I would save countless minutes of time by doing this. Didn't work. Guess what I had to do? I had to get down on the ground and pull it out. How long did it take to pull it out? Approximately 37 seconds. How long did it take to push it back in? Probably 42 seconds. Maybe 43, maybe 41. I wasted 5 minutes trying to do it the wrong way because I thought I was going to save time. Now that's not to say that you shouldn't try to save time when you can. That's not to say that you shouldn't try one way if you think it's going to be successful. But how often do we try to save a minute or 2 minutes worth of time and spend 10 or 15 minutes doing that savings? Kind of reminds me when my wife comes home from Kohl's, I saved $100. How much did we spend to save $100? How much time are you wasting trying to save 2 minutes? That's my rant for today. What's good?
Right, so, what is really technique of So we talk about having the public Christmas tree and taking it almost and putting the wrap around it. Then you tell yourself, you know what, you just want to put it in the front. But you got the same effect, right? You're just trying to do a shortcut it. So, that one. No. Right? Now, at the end, you also spoke about, yeah, you should have done it right the first time. But sometimes, a shortcut is help, right? If you're in a rush. I know with our class, we've done polynomials, right? So today we're going to tell you Remainder Theorem. And why should we use the Remainder Theorem? Because if you want to find the remainder of divided into polynomials, because we did that right? Let me just do a little recap. Let's divide two polynomials. Wait and see. Have a polynomial, let's see. Divider, right? And then when you play with pin and stuff, we end up with the answer, and sometimes you get a remainder. So remember the process of it, how long it was, the division and stuff like that. So remainder theorem is kind of like a shortcut. right, to find a remainder without going through all those steps. Okay? So what is the remainder theorem? So, like I said, it's a shortcut. Like you said, includes a polynomial, some divisor, right? You want to find a remainder. So, the statement is, the remainder theorem states that when a polynomial, some p of x, some polynomial, what's a polynomial?
Multiple numbers.
So it's numbers and something else. And what's the letters called? Variables. Okay, good. So it's coefficients and variables, right? When that's divided by some linear function, we get the remainder by putting that answer in it and solve it, right? That's not familiar to you. Now, since you're all good in mathematics, I have a question. Suppose we have this polynomial here, right? And we want to divide it by that linear expression there to find out what's the remainder. I want you to teach somebody how to do it. Understand? So somebody in the class here, I want you, pick anybody you want to pick with. I have three of you here, three of you together. Who cares? Teach somebody how to do it in your book. So it's 5x cubed minus 3x squared plus 4x plus 1. Right, so don't feel because you being taught again. If somebody teach you, then teach it to us. Right, so let's explain these steps.
Zero. And we try and find a number. So we go across negative 1. X. So we divide x minus 4. And we do x minus 1. And the subject. So we have a minus 1. And we have a minus 1 in 1. 1, positive 1, right? So x is equal to 1. So the formula, and you do here, you just substitute the 1 into the x. Like this one. You think so?
Yeah, I think so.
So 5 minus 3 plus 1 plus 4 equals 2.
So it is x minus 1 is a factor, so it equals to 0. Every time a number crosses the equal sign, it will turn into the opposite. So minus 1 is equal to plus 1 or just 1. Right, and then every time you see x, you just substitute it with 1. So it will be basically we have here 5 in brackets 1 cubed minus 3 in brackets 1 squared plus 4 in brackets 1 plus 1. And then you just work it out. You simplify it basically.
Square
Plus 4
See this one I don't miss it, but yeah.
1 in brackets.
Hold on. side of the how much I
It's easy to like this one.
so one by one, if you want my one,
Yeah.
five by one. But five by one, right? Five by one.
Let's put, since all of them equal to 1, just put 3 take away. Or 5 take away 3 plus 4.
So you gotta explain how we get it, right? One by one. Basically 5 by 1, which is 5 by 1 is how? 3 for 5. And when you do the rest, you study here. That was explaining what's in it. So. Oh, nice. Now, use the calculators. Oh, we two calculators. Use the calculators. Use calculators. 4.
Right, so I'm going to play a game here, right? Since you're got the idea online, about the competitive nature. So, I want you, your group, to make up a polynomial.
Start.
You have to pick up a polynomial.
And then some high, right?
And you will them, and they get value.
You will add it on the phone.
Now, the image restriction is you make it bigger than anything
Jesus.
cube, right? Cube is just cube.
So, because we got off this next, we cut off this one, and this is this. Cut off this, we go down to it. Are you not to solve this one? Are you not to solve this? No, you know to solve it?
I guess one is equal to
Okay, we use our one.
Wait. So we using it, right? Just to subtract 3. Let's use it.
No, but you can have 2 cubes in here and 1 cube.
Then just use from before.
You use this section and this now. And we're using this divider.
so say you create a polynomial and you revise it. You can give them
4x.
evil laughing.
Minus x minus 2 equals to 0. And we back here. That's the formula we put in. We get it.
So we are to solve that.
You can solve it. I have the answer. Minus 20. Okay. That's 2 answers here. 70 answers. This one is one. It does look.
And then we can have 3 meters
Well, let me get good, huh?
Yes.
Come in good.
Yeah, taking long to make the question, and you get some real answer.
Yeah, because in my head, you're wicked. You're wicked. Because you get it. Yeah, but I'm getting one of the boss. Watch
Right, so you'll tell them right alongside.
Oh, you want it?
Yeah.
You want to see the book or you want to tell me? Right. So the question is 4x cubed minus x squared minus 16x minus 12 divided by x squared minus x minus 2. Yeah.
Alright, let's stop here there for a minute, right?
Okay.
The divisor And a be linear.
Yeah. Linear means that's 2.
Yeah. So it's like x minus something.
No. Catch it right. Come now, okay. We go do it easier then. X squared.
No, leave your falling over here. Just change your device.
Yeah, change it.
Yeah, let's change the device. Right, change this.
We're gonna change it to that. We're gonna make it harder then. And we're gonna look back and we see that. That's not give you what I'm doing. You can't get on this too easy. This too easy. This too easy. This one? Oh yes, right. Nice. We do. So scratch out the whole device.
Yeah, just change the device. Huh?
Yeah.
We can undo this, right? No.
Yeah, sorry, tell them. What?
We taking this one?
Yeah, that one already.
Why that now? This one? That is from the right. 3x
Minus 2.
minus 2. Dog, this guy is easy for you, man. Dog, it's he. Yes, I
So give them your own question.
Alright, you say.
Me? Alright. 3x cubed plus 9x squared minus 6x minus 2 divided by 3x plus 1.
Mine. Yeah, plus one.
Oh, ole. Pull that card on me. Yeah.
Right, so it's competition.
There we go. Oh my god.
The best I group you will get, right?
Right. 3x, I don't know. Equal to 0. Then 3x is equal to -1. And then you put x is equal to -1 over 2. Nice. 1, 2. Nice. So we have what? 3 and -1, 2. Yeah, -1, 2. Cube plus 9, -1, 2, square minus 6, -1, 2, minus 2, Nice, we are good there. There we go. Then I'm find the visualize 3 negative and positive and negative. That's -3. So 4 cube. Oh, nice. That's 3. -1. 3 by 3 is what? 27. And then negative what? 3 squared is what? 9. Yeah, minus 6. -1. 3 minus 2. Nice. Find the LCM. LCM on 27. 1 by 1. 1 and -1 positive, and negative 3 plus 9 to 27 is 3 by 1 is 3 nines 27. But we have to get this quick enough. 3 to 27, 9 1 is 9 by -6, negative 3 by 9 by 1, negative positive, negative 9 by -6. Positive 54. Nice. Minus, we get it. Minus 3 plus 37 plus 54 minus 2. I think we get rid of it. This is more fun.
I mean, the denominator.
That's from before. It's 3 by -1 and then by 9 by I know I was gonna get there. Sorry. -3 minus 27 plus 54 minus 22. I think so. Right, so let me do it. 27 to 27 plus the one negative and negative. Hey, we're doing this one right. By 1. Nice. 27 to 27, 1 by -1, 1. -1 by 3 by 3, -2. 9, 27 divided by 9 is 3. 3 by -1. Positive 9. -27.
I don't all that we get different.
27.
It would be wrong if all that we get the same one.
27. divided by 1.
So they get something.
Yeah, we get something too.
Was it done?
Yeah, we got 9 into 27. Right. We already get that. 3 into 27. 27 divided by 3 is 9. 9 by negative 1. And 9 by 6 is how much?
Right, so
9 by 6.
it's done.
By negative 6 by so it's positive 4.
Yeah, get something.
Yeah, you're gonna get negative stress.
So, right, so were you agree? What do you get on, bro?
Oh, what's the answer for you?
We get minus 592 over 27.
Yeah.
What do you get?
Oh, we get 22.
Dialect?
Isaac? No, Isaac?
I don't know. So we should
All the words go to the sums.
So what you have to do for homework is do the division of it. The long division.
Alright.
Right? So do the long division.
The long division.
And
Wow, we get positive. Be positive.
saying that these days is now.
We show that.
Right, so you're sure? You're certain?
Yeah, we see.
Cool, no problem.
We see that we went from the beginning to the end 3 times. If they know wrong, it can be 3 times wrong.
So the next step in this thing is to solve one known coefficient, right? So you have a polynomial. You have 6x cubed minus 7x squared plus kx plus 7. Yeah, so k. So some unknown value k. They also tell us that if this thing is divided by 2x minus 1, the remainder is 3. What is k?
2x minus 1.
Any ideas?
Remainder is 3. So let's see if I can write 2 times.
So think about it. Right? Obviously we use what formula? What's theorem? Remainder theorem, right? I mean that's what we would say. We have to use remainder theorem somehow to figure out what this k is. So the idea is
2 plus 1 is 4. 2 to 2
so
is 3. No, it'll be 2. K is 2.
listen to what Saif said. Saif said do the opposite. Right? So what do you mean by that? So we have to utilize the remainder theorem, right? In some way that is
So I think I do it here, remainder theorem kind of way. But 2x minus 1 is equal to 3, right? So as you say, with the equal sign I can do it, right? So I bring across the plus 1, negative 1, I get plus 1, so 3 plus 1, right, on top, and then I get the x. Yeah, from the 2x, I get the x equal to 3 plus 1 divided by 2 because of the multiplying on the next side. You can do like that.
You're close. So you're on the right track. Right? Think about what we just did for remainder theorem. Right. Remainder theorem, we wanted to find the remainder, right?
Yeah.
By doing what you did there, manipulate the linear and plug it in the polynomial and you get your answer. So, if they already give you the answer and they give you the linear to find your x and something is missing in the polynomial itself, could we do anything about that? You create
Yeah.
something.
I think
You continue like normal.
Right, so you continue like if you was doing a regular theorem.
So, yeah, like what Ford say with the divisor, but I will come up with 1 over 2,
Good.
right? So you do the same, you replace the x, and when you reach the third step, where you will have to find a LCM, that is where
You'll agree with what you say.
Yeah, so
Yeah, he's going on the right path, right?
Yes, yeah, I find you wrong.
So you said you first thing, find your x value from your linear, you plug it in, when you plug that in, you know, we have some K to deal with inside of them. When you plug in your value, this first part will work out to be some number. The second part will be work out some number. The last part is a number, so you have to work out. But that kx part, you're going to end up with what? If you replace the x. K
In brackets, 1 over 2.
right, so you still have a K to deal with. But everything else is numbers, right?
Yeah.
And since it told you what the remainder was,
3.
can we equate it? Because
That means you put the 3 as K in this formula.
think about it, when you plug in your value in the polynomial, that is equal to the remainder, right?
Yeah.
So if you plug in your value in the polynomial, and I think I just said, it will be equal to what? Hmm?
It will be equal to 3.
It will be equal to 3.
The whole thing
The whole thing will be equal to 3. Right?
Yeah.
So the only thing we have to do now is try and figure out what our K is. So you have something plus something minus something K equal to 3. There were numbers. You will say that not a number, there is what?
K.
Could we manipulate that to figure out what K is?
Yeah, okay. So,
Let's try it.
yeah, you try that? Yeah, it's skipping so much pages. Yeah. Skip about 1 page over there.
So this is, yeah, well, this is equal to 3.
Wait, faster. Because the K, I don't know the case, I can't multiply by K. We don't know. Oh, we are adaptive. We are adaptive. All numbers. So 6 plus 1 minus 1 plus 7. I mean, never find this part. Because I never find this part. I don't find it. You explain it. I don't know. Okay, so you just do something because of 6 minus 2 plus 7.
You're right, yes.
Or what we do? Because you explained it. That one, and I tell me, right? You block out the cake, and let's do this one. I see that one?
It is right. 11.
You see 11?
That's right, 2 scrap.
2 by 11 is 22 by 22 is 22. But I use the LCM, I'm going to 4 into 8 is 2. Yeah. So we need a different number.
Oh, I think I understand. I want to take your key value.
So please tell me what I need to do.
Right.
You say cut it off.
So instead of these 5, it's K over 2, right? CM is 8. So 3 by 8 is so if this 2 into 8 is how much?
4. Oh, okay. No, 4K.
Right, so actually, 2 is the whole thing is supposed to be equal to so this one. So this is 7 over 1. And same as 8.
Yeah. So, but no, it is 1 over 8. 1 into 7 is 1 into 8 is 8.
8 times 7.
So I just always get messed up with the last step in a row.
56, right?
Physics. 56. Right, yeah. We start with this step then. 6 minus 22 plus 4K. Eight by 56, 8 by 7. 8 by 7. So it's not 56, it's not 56. So wait, you got 4 times K is okay. It is equal to 2K. So what's it 4K? 2K. Shut up. 2K, yeah. 2K.
1 into 4.
That's how. 6. Sometimes you know it. Yeah, go ahead. You know, that's all. I know. He didn't like it last time. He didn't like it last time.
And you know, the whole thing is supposed to be equal to
So you see,
Say 37. You get 37 from me, you get 3.
No,
Six minus.
Now the whole thing supposed to be 8, right?
No. I already picked the right here.
And if you want to get rid of this one, what is it supposed to be?
See, multiply line.
Yeah.
This 24.
This equal
To 24.
to 24.
Nice.
So, what we are going to do is when we find out everything here,
We find out that we can find out K if we didn't get my number.
right, so then we add a minus this, the answer, and without this, the final equation.
Explain again. How you go? So, right. You can not 6 minus. So 24 minus 6. So explain the difference.
Right, watch this though. So we say,
No, like this in order, right?
right, plus
This would be
5 is equal to 2 plus something is equal to 22. Plus, right, we use the same key.
The number is less.
We use the same key, right?
That is easy.
It's
And subtract from this. But key on one another.
Oh, so it's like because like
Right, so let's have a look at the solution.
So take out K.
So guys, let's look at the one. Let's look at the discrete.
Yeah, that's how the graphics right.
And then we go through the answer, right?
Okay, so 6.
So, the first step is to a divisor equal to 0. Right?
6 minus 23 plus 4.
The second step is to put the answer. Well, we're trying to get rid of the 1, right? So if I add 1 to both sides, I'll get what?
see what? Start what?
So the first step
Right.
was putting a divisor equal to 0, right? Trying to get rid of this negative 1 here. If I add 1 to both sides, 0 and 1 is 1, right? Negative 1 and 1.
1.
Negative 1 plus 1.
Oh. Negative will be so
So what will be left with on that side is 2x
Right.
equal to 1, right? Now we're going to get rid of 2. If I divide both sides by 2, 2x over 2 is what? X.
X equals a half.
The next step after that
Come to change the start.
is substituting a half into the thing, right? So we've got all the indices. So half to the power 3 is
Half equal 1/8.
1/8 after that.
1
Half
quarter.
square is a quarter. Right? So then the next step will be to multiply those fractions by the coefficients. Understand that part, right?
Yes,
Let's
sir.
multiply the coefficient by the fraction. So then we have a bunch of fractions there. So when we want to add or subtract fractions, we have
Yes.
and 7 in this case will go to the 8.
How is it 8? Oh, I thought
Yeah, 7 is 8. So we say 8 into 8 is what?
8 into 8, 1.
So 6 times 8,
1.
6. 4 into 8, 2. So 2 by 11. 2 into 8, 4. 4 times 8.
Okay.
1 into 8, 8 times 7.
56.
Right, so you talk over the 8 is what I have, right?
Right, and we step by.
Right. Then you simplify that.
You can simplify that.
So 6 and 56 is how much? 62. 62 minus 20. I mean, sorry, minus 22. 40. So on top, all you will have it is 40 plus 40, all over 8, right? All over 8 still, right?
Yeah.
So let me just simplify that even further. So 40 divided by 8 is 5. 4k over 8 is k over 2. So all of that break down to be k over 2 plus 5. Now, we say the overall thing is supposed to be equal to 3 for the remainder, right? So if I equal to 3, so k over 2 plus 5 is 3.
Only get 40, I get 44.
They try and get rid of the 5. So we
You minus.
I like to say, like to add the negative of it on both sides, right? To get rid of this one, so it's positive 5 and it's add negative 5. Okay. But since I do it to one side,
I think
I do it to the next
you
side. So we're going to go 3 minus 5. Right?
Say also money
Right? So we have another just being k over 2 equal negative 2. This is supposed to be division sign, right? But it's real. So we divided both sides by half, or you can multiply both sides by 2. But dividing by half and multiplying by 2 is the same thing, right? So they get rid of 2 underneath the k. So if I multiply by 2, so this is the k, and negative, like again, you do something on one side, the next side. So negative 2 times 2 is negative 4. Right?
It's just what talking about.
Nah,
Talking about negative 4. It's negative 4. They are trying the whole 4.
So my question is now,
plus the 4 minus negative 48.
you know how to do long division, right?
Yes.
Now we do remainder theorem. I'm going to need to get in with the fellows up like the Christmas tree and shortcuts and
We are free.
right? In your opinion, which one you find is better?
I ain't gonna lie. Long division.
No, I'm not wrong because remember at the end of the day, it's your opinion. Right? You can't be wrong about your opinion. Now we gotta explain why. Who said theorem?
Remainder theorem?
Yeah.
I think
Justify it.
I like it more because if you make a mistake, it'll be easier to fix. It'll be easier to fix than long division. Everything, yeah.
So you can fix the mistakes for you.
Yeah.
So you recently, so you all think it's easier to fix mistakes rather than which is true, it's easier to correct errors or prevent errors. What are you saying? Long division?
Yes, sir.
Why?
It's a long division because what? Again, it's simply it's simplifying it more so you can see it in a different way, and when you bring it back together, I think the thing will be easier. So you know if you went wrong here, you go back to make the correct steps.
Fair enough. Fair enough. What do you say, Anna? Long division? Alright, you prefer to read. You prefer long division? You don't have a preference. That's fair because at the end of the day, they both have the pros and cons, right? So like with the theorem, we can figure out what the remainder is very quickly, right? Also we can figure out the unknown coefficients in the theorem. You can't do that with long division. However, with the theorem, what's the answer? We know what the remainder is, but we don't know what the answer was. Yes. Okay, now when you do long division at the top, you end up with the answer and the remainder. So you see, both of them have a purpose, right? But it's just what you use it for. So if you want to find the remainder quickly, you need a theorem. Right? If you want to find some unknown coefficient, you need a theorem. If you actually want to find the answer, it's long division. Right? So everything have a pro and a con, right? So slower, but take more time. Alright, it take more time to do long division, right? So what we learned today, is that there are more than one ways to reach the same place, right? And each route might be different. The long way might give you more answers, the short way will get there quicker. But it's up to you. So, for your homework, you created this Google page, right? So all your notifications, your coursework, everything is on there. If your email address, if it is not correct, just see me and I'll fix it. All your notes, all the exercises, everything will be sent here. So you could always go back and look at it. And it's a good way to keep track of your work. And even like Michael's still home, he will still get in. Right? So guys, I just want to say thanks. You all are always a good class. Right? A good class doesn't necessarily mean just sit down quiet and take notes. You interact, that's how we learn. Right? Because with people are social creatures, and that's how we learn. Right? So next week, I see you all. And again, the Google Classroom there for any questions or anything. Right? Thanks for coming.